Alright, ladies and gentlemen, we're going to take a few minutes in Lesson 7.3 to talk about interpreting graphs. And so the two keys that we want to be able to do when we finish here is when we're given a graph, can we interpret what it's telling us? And then two, can we graph a model of a situation? So we're going to start with the first thing and start interpreting graphs. So here I have graphs of snowboarders during a race, and this is their speed as they go down the hill. So as the time of the race continues from their start to their end, what happens to their speed? Okay, so and down here we're going to do a little bit of matching. We're going to match the situation to the graph and vice versa. So here we go. Jordan gets off to a good start and continues through the course picking up speed. Alright, now based on what I see up here, I'm thinking that graph 1 is probably the best solution, because this is Jordan. If this is Jordan, he's picking up speed, and even here his speed slows, his acceleration slows, but he's still picking up speed. He's just not picking up his speed as great of a rate as down here. This person here picks up speed, still picking up speed, and then something happens, probably a fall of some sort, or just a significant part where they slow down significantly, and then they start to go up again. This person here picks up speed, levels off a bit, picks up more speed, but then at this point their speed is constant, okay, throughout this segment, but then they go faster. So Jordan gets off to a good start and continues through the course picking up speed. I'm going to go with graph 1 on that one to begin with, and if I find a better choice, I'll come back here and change it. So Ethan gets off to a good start and picks up speed. Toward the end of the race, he nearly falls and his speed stops increasing, and that is an important piece right there. His speed stops increasing. He rights himself and he finished the race, reaching his greatest speed. So in these two graphs here, the key part is his speed stops increasing, which leads me to believe that we're looking for that piece right over there, where yes, he's picking up speed, levels out, but still gaining speed. This part right here, his speed stops increasing. Graph 3, and it is near the end of the race, which we are indicated in the story here. So, and then Xavier gets off to a good start, but he falls around the middle of the race. Well, here looks like the part Xavier's good start here, but there's the fall. And so in that particular case, that tells me that graph number 2 goes with C. Okay, so the ability to be able to look at a graph and have an idea of what it tells us to do, or what is happening through the as time progresses, is important. Now I want to take a second here to talk about two different types of graphs. The first one is a continuous graph, and this is a graph made of connected lines or curves. Okay, and as an example, if I pull one of my snowboarders out of here, this was the guy who fell. You'll notice that this is made up entirely of, in this case, straight line segments. And the reason that it is, why it's continuous and why we would, so to speak, connect the dots from time to time, is because the speed in this case is happening throughout. It's changing, it's moving, it's going up and down. But the speed is always occurring. And so, because it's always occurring, the action is always happening, we're going to go with a continuous line or a curve. Second type of graph we're going to talk about is a discrete graph, and this is a graph made up of unconnected points. And now here's an example of a graph, the cost of printing photos. So we have the number of photos down across the bottom, and we could number this, 1, 2, 3, 4, 5, and so on. The cost of those photos on the y-axis. Now the reason that this is not continuous, why it's discrete, why are we using dots, is because this information in the middle doesn't make sense. Okay, and what I mean by that is if this is the cost of one photo and this is the cost of 2 photos, okay, probably not going to buy 1.5 photos, 1 3/4 photos, 1 7/8 photos. So this information in the middle doesn't make sense. You're not going to buy 1.5 photos. So in that case, we're going to simply plot the points of the things that actually will happen, and we'll leave out the stuff in the middle because it doesn't apply. So Create a graph for the situation. Tell whether the graph is continuous or discrete. Okay, so it looks like we have airplane altitude. Alright, so in this particular case, let's go ahead and graph these. And you'll notice I've already attached scales. And you'll notice my scale is actually going by tens. I didn't put the tens in here because this would be 10, that would be 30, that would be 50, and so on. But so because I have a grid line, so to speak, at every one of these, I have to take into account the middle too. So this is going by tens. Here we're going up actually by 5,000s. I just labeled every 10,000. So okay, 0, 0. I'm going to go ahead and I'm going to plot my points. 0, 0. 10, 10,000. 20, 20,000. 30, 30,000. Okay, now 60, 30,000. So over to 60, up to 30,000. 70, 20,000. 70 would be right here. 20,000 would be here. 80, 10,000. And then 90, 0. So 90 would be here, and here would be 0. So this is time in minutes. So this is the altitude of the airplane throughout the time. So right now I've done a discrete graph because it's got dots. Now the question we have to ask is, does the information in between the dots make sense to us to record? Okay, would it be important for us, maybe, you know, at in this particular case, let's say at 5 minutes, would having that information in the middle there be sensible for us to use? Okay, and for us to find. Is it possible to find the altitude at 5 minutes? The answer to that is yes. So because this information in the middle is valid for us to find, then we will go ahead and we will connect the dots. Now in this particular case, I'm using my little line drawing tool. Okay, so that information in between is relevant. It might be useful to have, and so we'll go ahead and we'll connect the dots. Okay, now ticket costs in this particular case. So we're ticket cost to a concert. The cost of tickets is $15 each. So in this particular case, I'm going to go ahead, and you'll notice I don't have a table. I'm just going to go ahead and plot them. So one dot, I wish I would have done this on the previous one, is $15. Oh, I'm going by tens here. So if that would be 10, so 15 would be right there. And 2 tickets would be $30, which would be right there. Again, this would be my 30. And 3 tickets would be $45, and 4 tickets would be $60. 5 tickets would be $75, and so on. So we go ahead and we place our tickets, $90, $115, and so on. And now I've run out. Now the question is, should I connect the dots? Now here's the question, I guess, that we have, and whether we do or not. Would it make sense, let's say right here, that looks like a half. Would I buy half a ticket to a concert? Well, the answer to that is no. You're not going to buy half a ticket. And so that makes this information in between irrelevant, because we're not going to buy a half. We're not going to buy 2.5 tickets. We're not going to buy 4 3/4 tickets. So having the line in between doesn't do anything for us, because we're not going to use that information in between. We're going to buy whole tickets. So in this case, we're not connecting the dots, so it makes it a discrete graph. All right, that gets us to the end of lesson 7.3. Any questions, issues, and so on, come see me. Otherwise, good luck on your assignment.